in there somewhere. Should be it. And then here's the kidney. Kidney's pretty easy to identify in fish. They're all pretty much right up along the dorsal part of the coelom, and they're bright red. Urogenital. Uro again means back, but that's in reference to the urinary system.
What's different in the morphology between fish that can be in both hyposaline and hypersaline condition, like a bull shark or something like that? There are no fish. We'll talk about what the body has to do in saline conditions versus non-saline condition. It takes a physiological change. They can make the change, and once they make the change, say a salmon comes in off the ocean, it goes through a change for about 3 days, and then it can handle fresh water. Once it's done that, you throw it back into salt water, it's going to die on you. So there are very few fish that can actually live in salt water and fresh water, or freshwater, salt water interchangeably. They can withstand certain conditions for a period of time. So we think of them as being, wow, they're highly tolerant in freshwater and salt water, but it's only for a short period of time, and even then they'll succumb to it. Including bull sharks? I've heard of some that are stuck in certain areas that are only freshwater and they've been surviving.
So the sharks in general, because of a couple of things, are not, very few sharks, due to their osmoregulation, conrictes, can inhabit fresh water. Some of them do. But there are some bull sharks that seem to be doing quite well in fresh water. My understanding of those are not going back out in the ocean, hanging out, coming back in the fresh water and hanging out. There's all kinds of changes that have happened for them to survive in that fresh water. In Texas, furthest instream a shark has been found. Any guesses? Brazos River. How far up? Waco.
Wow. Holy
Yeah. He was lost, was not doing good, but he was in there probably several weeks.
I'm good with it.
What do you want me to tell you? 20 feet? 20 feet. 2 children in Waco. There's a monument up.
That wouldn't surprise me.
Waco folks are very superstitious. All right. So let's look at switching over to the circulatory system. This bag here that you're seeing is called the sinus venosus. Sinus in the circulatory system world, sinus in the bone world means a cavity. Sinus in the circulatory world means a cavity without muscle. So that's the reason why it's a thin connective tissue. You don't see any muscles around it. All the blood in the body, and we'll diagram this all out a little bit later, but all the blood in the body comes to the sinus venosus at some point. From here, then it is pumped into the atrium. Keep in mind we've got this fish upside down. So here is the atrium. From the atrium, which is a flaccid sac here, it is pumped back into the ventricle. Yeah, stick your nose in here if you need to see it. Just don't breathe when you do it. Atrium, ventricle. If you're to cut that ventricle open, you might be somewhat surprised to find that the cavity is pretty tiny. It's a tiny cavity inside there. That's because it's got all that muscle mass around it, and that's the primary ventricular force that propels blood, but it's not the only force that propels blood into the body through the circulatory system. From here, from the ventral aorta, or from the ventricle, it goes into a couple of different names. I just call it conus arteriosus. It's called something different in sharks, bulbous arteriosus, I think in shark, I can't remember. Just know it as conus arteriosus. From the ventricle, it goes into the conus arteriosus. The conus arteriosus is primarily an elastic fiber. And it's a lot better to view it on the bony fishes because it's a white structure. And what it does is it accepts the ventricular force and it spans out. And then it slowly shrinks back in to give a more constant flow of blood going through the gills. So fish tend to lack a pulse. It's still there, but that conus arteriosus takes most of it and then slowly, steadily pushes it through the gills. From here, you'll see past the conus arteriosus, it turns into the ventral aorta. The ventral aorta splits 4 times. 1, 2, 3, 4. 8 if you count both sides. 4 splits. This split, which I'm pointing to here, that's the first one, is called the afferent branchial artery. Afferent going to, branchial means gill. This is going to the gill. So blood goes from here, diffuses into a capillary network of the gills. And what's it doing there? It's picking up the oxygen.
Dude, I haven't done it. Oh, today.
Except I have to get a pro.
It's only an hour and a half.
So it's picking up oxygen. So notice it's starting ventral. And it's coming up dorsally around the gills. And which way is the blood flowing? The water flowing? Water's coming into the mouth. Blood's flowing this direction. Water is flowing the opposite direction. Countercurrent exchange. And it maximizes the pickup of oxygen. From there, and notice 4 because there are only 4 gill supporting bones. So can you flip this skull over? Yeah, and let's look at that branchial apparatus. You've got the lower jaw, you've got the Howell series, and then you're going to have 4 gill-bearing gill arches. And if we're looking here, it's just like with the Howell series. You're going to have a basial Howell, hypohowel, serrata Howell, and epihowel. And there's 4 of them in there. Now what this one is, what's missing on there, so we've got 1, 2, 3, 4, maybe right there. That is the branchial pharyngeal teeth. Turn around on that other part there, and there's a pad sitting in there. And that's all part of the branchial apparatus. See a big, no, there's like a bone pad in there. Got little molar teeth on top. You see it anywhere in there? Yeah, that's it. Toss it up here. This is the bone, just like this is called, is a serrata branchial. It's a serrata branchial bone, but now this has lost its gill arches. There's only 4. This would set, not in the species, would set back behind here. Now, the pharyngeal teeth are the serrata branchial bone. Pharyngeal teeth on this specimen here, it's a crushing pad. In minnows, that's what you have to pull out to help identify it. We'll show you a way to pull the pharyngeal teeth out to look at it. So that's the pharyngeal apparatus. There's 4 of them.
Is that what that
Hmm? Yeah, that'll kill it.
Minimum spending is always.
Yeah, you can't hardly handle them without it dying. So, oh, got me. So, afferent brachial arteries, capillary, efferent brachial arteries. How many of them? 8 total, but there's going to be 4 on each side. 1, 2, 3, 4. Efferent brachial arteries means it's going away from. So these are the afferent, these are the efferents. You want to get a closer look, Emily? Everybody good with the efferents?
Is that one of the recommended books?
So now, these are all, this is all, it's all dissolved oxygenated vessels. This is now the artery. What is an artery? Anything that moves away from the heart. So starting with the ventral aorta, all of this is an artery, but where does it start to get oxygenated? Only in the afferent is where you start getting the oxygenated blood. Now where does it need to go to? Everywhere from here. One of the first places it goes to, and you can see the vessel right here. I think it has a certain name. Doesn't matter. Let's just know that one has the jugular. Nope, not the jugular. Carotid. That's the carotid artery. Because that is one of the ones that goes to the brain. You see the vertebral artery here? That is also going to the brain.
Where are you pointing? Right here.
Because here is all of your afferents, efferents, split off, goes to your vertebral artery going to the brain, and then up here it's going the carotid. Whenever you get really hot and you hear pounding in your ears, that's your carotid, because your brain's trying to cool down. Continuing on back. Everybody good with that? The first split, well, I'm not going to show it here. It's one of these I'm probably cutting through. Coronary artery. It's got to send blood back to the heart. All this.
Oh, this one.
Coronary artery. The heart's a muscle. It needs oxygenated blood. In your body, for both men and women, you have a high chance of dying because of coronary disease. And it doesn't make sense to me. Right? Your blood has tons of oxygenated, your heart has tons of oxygenated blood, and yet what does your heart do? It doesn't take any of it. It sends it out and has to come back through the coronary. Why? It seems like an imperfect design. Ancestrally, there is no oxygen in the heart. It had to go out to the gills. Is that me or the shark?
That's you. You're doing pretty good.
It had to go out and then come back around. Our body's still designed that way. Don't wrinkle your eyebrows. All right. Besides the coronary artery, one of the next major splits is going to be the subclavian vein that takes it out to all the muscles and everything associated with the pectoral girdle. Come back a little bit further. See all of this big vessel here? Comes out right here, and that's the celiac artery. Celiac takes blood to the upper portions of the gut tract. It will, if it goes to the stomach, it's called the stomach artery. If it goes to the spleen, it's called the splenic artery. But just want you to know now the celiac takes oxygenated blood, and what else is it carrying? Just not oxygen. It's carrying nutrients that it's picked up, and a variety of other things. So we've got the celiac, and now all of this is called the dorsal aorta. Ventral aorta here, dorsal aorta here. You'll notice that you'll have a lot of segmental arteries. They're called a couple of different names. If it's inside the coelom, I think it's called parietals, and once it moves out through the coelom, it's called segmental, vice versa. Just know them as segmentals. Notice the segmentals coming out here. So where is blood going to in the segmentals? Probably to the skin, but also definitely to the muscles. Continue back here, and you'll have a mesenteric artery. And that's going to service the lower portion of the gut tract. And then rectal gland, rectal artery. You come on back, the dorsal aorta. Notice the difference between this size artery and the rest of them. These are tinier, this is larger. That's the iliac artery. The iliac artery breaks from your dorsal, what's it called in humans? Is it the dorsal aorta comes up, and what's this called comes down? Call it still the aorta. It splits into the iliac artery and goes into your legs. Iliac artery here, homologous structure going out to the pelvic fins. At that junction, where the dorsal aorta splits into the iliac artery, from then on it's called the, recall? Caudal artery, going through the humeral canal. Very good. You can see again a lot of these same arteries on a fish, on a bony fish. You can definitely see the dorsal aorta. You can see a lot of the heart, the ventral aorta. So make sure that you go back into some of those fresh specimens and see as much as you can of those arteries. Okay, my phone is buzzing, so I need to make sure there's no emergency, and then we still have the nervous system to do.